Welcome to The Explainer. Today, we're asking a huge question. What's the real difference between, say, a rock and a redwood tree? Or between you and the chair you're sitting on? Well, it all comes down to this secret, invisible dance that every single living thing is doing all the time. And today, we're going to pull back the curtain on it.
Okay, so let's dive right in with a question you probably think you know the answer to. When you look at something, how can you tell for sure that it's actually alive? What's the real test?
Our first instinct is probably movement, right? A dog running around? Obviously alive. But what about a dog that's asleep? Or a tree? They're not exactly doing laps, but they're definitely alive. The tree's growing, the dog is breathing. The movement is just way more subtle. So yeah, what we can see with our own eyes, it's just not the full picture. But if you really want to know the secret, you got to look way, way smaller. Biologists will tell you the real action, the true signature of life, it's not running or jumping. It's this constant, invisible chaos of molecules moving, repairing, and building inside every single living cell. Okay, so that brings up a really big question, right? Why? Why is all this microscopic motion so absolutely crucial for, well, everything that's alive, from a tiny bacterium to a massive blue whale? So think about it like this. Every living thing is this amazingly organized, complex machine. But the universe actually loves chaos. It's always trying to break things down, create disorder. So life's entire mission, its whole job, is to constantly fight back, to repair and maintain itself against that natural tendency to fall apart. And that maintenance job, it can't ever stop. Not even for a second. The moment that internal repair work stops, that's it. Order falls apart. Chaos wins, and the structure breaks down. That's literally what death is. So this constant molecular movement, it's not just a sign of life. It's the engine that is life. So how do living things actually pull off this massive constant maintenance job? Well, it turns out they all use the same basic toolkit. Let's open it up and see what's inside. Okay, you can think of this as the 4-part job description for anything that wants to stay alive. First, you've got to get fuel and building materials. That's nutrition. Simple enough. Second, you have to actually burn that fuel to get the energy out. We call that respiration. Third, you need a delivery service, right? Something to get all those materials and energy where they need to go. That's transportation. And finally, every good system needs to take out the trash, and that's excretion. Now, when it comes to that first step, getting the fuel, life on our planet basically has two main strategies. You're either a self-feeder, an autotroph, like a plant, which is kind of like a chef that makes its own food from scratch, or you're an other feeder, a heterotroph. And that's us. We have to go out and eat other things to get our energy. All right, let's start with those amazing producers, the autotrophs. How in the world does a plant just create a meal out of thin air using nothing but sunlight and water? Let's break it down. Well, it's all about the magic of photosynthesis, and it really happens in 3 main steps. First, the green stuff in the leaves, chlorophyll, grabs hold of sunlight. Then, and this is the really cool part, the plant uses that light energy to split water molecules apart. It's like charging a battery. And finally, it uses the power from that battery to snatch carbon dioxide out of the air and build it into carbohydrates. And that's pure storable food. Okay, so now let's flip the script and look at us, the consumers. How do we, as heterotrophs, get the energy out of the complicated food we eat? For us, the whole journey begins in what's called the alimentary canal. And really, you can just think of it as one super long, specialized tube that runs all the way through your body, from the moment food goes in to the moment waste comes out. And every single part of this tube has a very specific job. First stop, the mouth. It all starts here. Your teeth are doing the physical work, crushing the food up. But at the exact same time, an enzyme in your saliva gets right to work on the chemistry, breaking down complex starches into much simpler sugars. The breakdown begins immediately. Okay, from there, the food heads down into the stomach. And this thing is basically a muscular bag filled with hydrochloric acid. It's super acidic in there, which creates the perfect environment for another enzyme, pepsin, to do its thing. And its thing is digesting proteins. All right, from the stomach, we enter the longest and, honestly, the most important section of the whole tube, the small intestine. This is the main event. You can think of the mouth and stomach as the prep cooks, but this
This is where the master chef works. It's where the final, complete breakdown of everything, carbs, proteins, and fats, really happens. But the small intestine doesn't work alone. It's got some key partners. The liver sends in something called bile, which is great at breaking up big blobs of fat. The pancreas chimes in with this cocktail of powerful enzymes to finish off the proteins and fats. And all the while, the inside walls of the intestine are lined with millions of these tiny finger-like things called villi. Their job is to create a massive surface area to absorb all those good nutrients and get them into your bloodstream.
Okay, wow. We've gone from the inside of a plant leaf all the way to the human gut. So let's zoom back out. How do these totally different systems tie back to that big idea, that core mission of staying alive? It all comes down to one thing: energy. It doesn't matter if you're a plant capturing sunlight or a person digesting an apple, the goal is exactly the same: grab energy from the outside world. And for what? To power that nonstop internal maintenance job, that constant fight to maintain order and keep chaos at bay.
So you see, it's not just one single process. It's the symphony of all of them working together: nutrition, respiration, transport, excretion. As our source material puts it so well, the processes which together perform this maintenance job are life processes. It's the whole package that defines life.
And that leaves us with one last really fascinating puzzle: viruses. I mean, if life is defined by this constant internal movement, then what in the world are they? On their own, they're basically inert. They show zero molecular motion. They're like specks of dust. But the second they infect a living cell, bam, they spring into action. So what's the call? Are they just complex chemicals? Or are they something else entirely? Something teetering right on the very edge of what it means to be alive?